book. And the first thing I'm going to ask you to do is just graph a coordinate, 3, -4, and label it with the letter C. And remember that you have on the other side of your coordinate grid, you do have like a little hint if you need it. I know some of us haven't graphed for quite a while. So if you need that little hint, and take your best educated guess, where do you think that coordinate's gonna go? And most of us have got our good educated guess here. So remember that the first number tells you where on the x-axis that coordinate lines up with. So the x-axis is this way, going, or is our horizontal one, right? So +3 is right there to the right. So we know our coordinate is going to be to the right 3 because of that positive number. And then if I look at my second coordinate, -4, that is the one that tells you where it falls on the y-axis. And because it's a -4, that means it's going to be down. So where is the coordinate that lines up with +3 on the x-axis and -4 on the y? It's going to go right there. And pretty please and thank you, label. That's going to be really important in a minute. So if I say give it a C, please give it a name, give it that C. So what am I doing when I'm translating something? Like, somebody just tell me in your own words, what's it going to mean for me? We've been talking about all our different rigid transformations. What does it mean when you translate something? So we have translations, rotations, and reflections. Which one is translating? What are we doing when we translate?
Like you slide it over.
We slide, exactly. So just to make sure that we're all good and we're on the same page here, I'd like you guys to take that coordinate that I just graphed, or that we just graphed, I'm sorry, and pretty please and thank you, translate it, which Alejandra's right, means slide it. Let's slide it up 3 and then to the right 2. And let's just see where you think that coordinate is going to end up. So if you translate it up 3 and to the right 2, where do you think that new coordinate's gonna go? And I'm just kind of peeking and seeing. If we end up in the wrong place this time, who cares, right? You literally just learned how to do this yesterday. Oh, I'm seeing so many good ones. All right, so I'm gonna go ahead and go because you guys are that good. All right, so up 3. So when I go to graph my new one, I would literally count, like this is what I do because I'm really visual. I literally just kind of take my pencil and I just count like up 1, 2, 3. Can you guys see my little, I'll zoom in here a little bit so you can see my dots. So I went up 3, and then because the second one tells me whether I'm going to the left or to the right, once again, so starting from here, I would go over 2. So my new coordinate would be right here. That's what I would get if I go up 3 and to the right 2. Now, in math, whenever we take something and we move it, when we do some kind of transformation, you've got to be able to label it in a way that somebody can tell which one was the pre-image. Remember, pre is what it started out as before it moved versus the image. And this is how we do it. So it's still coordinate C, so we're still going to label it. But instead of just leaving it with just a regular C, we're going to put this little tick mark. It kind of looks like an apostrophe. If you're using like a keyboard, we'll just use the apostrophe for a substitute. And if I were to say this out loud, you don't need to write this, but just so you know, you would pronounce it C. Oh, it would help if I spelled it right because I'm getting ready to spell it wrong. C prime, like a prime number. So that little tick mark means prime. So this is called prime notation. So anytime you see two shapes on a coordinate grid and one has the little tick mark but the other does not, that means that it's been translated. So you know that this one is your original because it didn't have the tick mark. So this is the one that you got after you did the translation. Okay? So we're all good, I think, with the words, right? So we know what up, down, left, right means. So something that we math people do that kind of drives me a little bit crazy, you're going to hear me complain about it a lot this year, is that we will give 5 different names to exactly the same crap. I don't know. Like once we learn about something called functions, an X value is going to be the same thing as a domain, which is the same thing as your input, which is the same thing as your independent variable. 4 different ways of saying the same thing. Well, guess what? We've done it with transformations too. There's actually another way to describe how you're going to translate a shape. So we're going to leave this coordinate C prime. Okay, so I'm going to erase it to make a little bit of a clean slate here. Go ahead and erase that C prime, and let's go back to just our original C. And I'm going to ask you to take an educated guess. So this is what would be written on your paper, these words. It would say translate. You don't need to write this part just so you can see. And it'll say something like this. So you'll see an XY, say, oh my gosh, that just looks like a bunch of Greek. Okay, so first of all, because I have horrible handwriting, this says, so X plus 3, and that's a Y minus 2. That is not a Y minus a Z. I know my Z's and my 2's have a tendency to look like Z's, and I'm really sorry about that. This is another way of saying, hey, take that coordinate and translate it. But it's like a shorthand way instead of the words. So my question for you, friends, I don't want you to yell out. Jot it down on your dry erase board. If you were just to take an educated guess, that X plus 3 is a shortcut for saying up, down, left, or right. You don't know. All I'm asking you to do is take an educated guess. So jot down on your dry erase board the word up, down, left, or right. What is your guess? By saying X plus 3, I am asking you to move that coordinate. Do you think I'm asking you to move it up, down, left, or right? You can't possibly screw this up because it's just an educated guess at this point. Can't possibly mess it up. So, okay, so Edward, what do you think maybe it might be?
Right, down.
Okay, so let's start with, so first of all, Edward says this is another way of saying right. And that is correct. Okay, so the right answer, no pun intended, actually pun very much intended. I love a good dad joke. So more importantly than the right answer is knowing why that's the right answer. What is it about the fact, first of all, how do you know that you're going to the right and not like up or down? What is it about that placement? What do you think?
Because X is like right to left.
Yay, your x-axis is the one that goes from right to left. So, but why did we go to the right? What was the logical reasoning behind why we went to the right? Kaylee, I know you were getting ready. What's your reason for why you think it's going to the right instead of going to the left?
Because if it went to the left, it'd be going backwards, like negative numbers.
Oh, ding, ding, ding. If that had been a negative 3, that means you would be going to the left. But because it's a positive 3, that means that we are going to the right. Great. So using our logical reasoning, if the first coordinate tells us which direction we're moving, if we're going left or right, what do we think? Jot down your best educated guess. Y minus 2. Is that another way of saying up or down? Which way do we think it might be? What do you think? What do you think?
Down.
Why do you think it's down?
Because the y-axis is the one that goes up to down, -2.
Beautiful. The y-axis is the one that goes up and down. Negative numbers are underneath. Exactly. So this is a shortcut for saying take coordinate C and translate it 3 to the right and then down 2. So Everybody take just a second, jot down where you think that other coordinate is going to go after we translate it to the right 3 and down 2. Where do you think it's going to go? And let's use some proper labeling too while we're at it. What would the label look like? That's just as important so that you know which one is the original and which one has been moved. So I see a lot of you guys. So I would go, shoot, this screen. Do that while I was messing with my technical difficulty stuff. All right, so to the right 3, I would literally just count 1, 2, 3 to the right. And then I would go 2 down. So my C prime. Those of you guys that put the little tick mark on there, great job remembering that you need to do that. So to go to the right 3, down 2, we do our little prime. So we've got 2 different ways so far. We've got words and we have, this is called using the rule is what it's called. Guess what? We got to throw another one into the mix too because we just have to make things complicated for whatever reason as mathematicians. So everybody go back to just your plain old C. So go back to 3, -4, pretty please and thank you. That's what it was, right? 3, -4? Yeah. I'm going to show you one more way. So there's my C again. And you're going to be looking for words like this. It'll say translate. We're still always going to translate. And it will say the vector is -3, 1. What could that so it's still telling you to translate. It is still telling you to take point C and move it somewhere. But now we're using the language vector, and it's saying the vector is -3, 1. So this first number is a code for up, down, left, or right. Write down on your board. What do you think? Is that up? Is that down? Is that left? Is that right? Which way do you think that -3 is telling you to move? How is that -3 telling you to move? To the left, to the right, up, down? Oh, I did mine. Oh, that's been fault. I got to take care of that. Up, down, left, or right? What's your educated guess? Anybody want to share their guess? Because you can't possibly get this wrong. What you got? What you got?
Down.
Okay, so why do we think it might be down?
Because it's -3.
I love the idea that it might be because it's a negative number. We could definitely think that there's definitely a chance that it could be down. Great, very reasonable, educated guess. Somebody else, Journey, you got a different educated guess? So what's your, so right now we've got down for one possibility. Journey, what's your reason for left?
Because on the right side it was going to be positive, and so I'm guessing that the left side would be negative.
Oh, okay. When you graph a coordinate, which one comes first, your X or your Y? Your X. What direction is X? Left and right. So these are excellent guesses, guys, and I love, love, love. So this one is going to go to the left. And it's going to be to the left because your x-axis is the one that comes first. And so what does that mean? What direction are we probably going to be going in? This one must be a code word probably for, if it's a positive 1, I'm sorry. So, yeah, I didn't make that very clear. So we're going to go, so we went to the left for our first one. Since that second one tells us up or down and it's a positive, the positive numbers are up. Very good. So if I were going to shift this one, which I'm going to, I would just count. So I would start here and I would count 1, 2, 3 to the left. And then I would go up 1. And where am I getting ready to put what else am I getting ready to add to that C? So that anybody that looks at it can tell that it's been moved. I'm going to put that little prime notation. So that, friends, are the 3 different ways that you might see us telling you to translate. We might use words. We might use symbols, okay? We might use what's called a rule, or we might use what's called vector notation. Now, the bare minimum, I'm going to go ahead and tell you, well, not the bare minimum, I'm sorry, that's the wrong choice of language. The goal is that you can at least do it with words, okay? If the symbolism part is a little bit confusing to you, that's okay, all right? But as long as you can do it with the words for now, you're going to be in good shape, all right? But I know a lot of you guys can pick up the symbolic part really quickly too. So we're going to do one more together as a group. So, pretty please and thank you. Instead, we can't just stick to the easy, just one coordinate. You know, we got to make it harder, right? Because that's what we do in math. I'm just joking. We don't try to make it harder. But so instead of just graphing a coordinate, now we're going to graph a triangle. So those 3 coordinates are the vertices. Do we know what a vertex is for a triangle? That's the big kid word for the corners. Okay, so those 3 coordinates, does anybody need me to zoom in on those 3 coordinates? Can you guys see okay? Yeah. Okay, so please graph those 3 coordinates. I know you've been listening to a lot of talking. We're almost done. Promise. Then you'll be able to actually, I know you've had to listen to a lot of adults running their mouths today. This is the last one. Thanks for your patience. So let's get those 3 coordinates. Let's get those 3 coordinates graphed. Yep. Oh, sorry, honey. My fault. And then we're gonna shift it. A lot of you guys already have this, so I'm gonna go ahead and show you what it should look like. So because A is a +1 and a +3, that means that A is going to be up here, because B is a 0 and a -2. Don't put it here. Do we remember, if I write something in red, do you guys remember what that means? It's wrong, yes. Anytime I give you guys examples, if you see red ink, that means I have deliberately made a mistake. So this is a pretty common mistake that I see from people a lot, is that they put it on the -2, but guys, that's the -2 on the y-axis. So it shouldn't be going there. It should go down here. I've been doing this for so long, it's like I literally know some of the mistakes you guys are going to make ahead of time. So it needs to go there, not on the x-axis. And then finally, our C, because they're both positive, is going to be right here. So let's start off with that A and that B and that C. Oh, that's ugly. So that A, B, and C. And of course, because we've been translating, right? So I'm going to ask you to translate this, and I'm going to ask you in 3 different ways. So first, I'm going to show you with the rule. And again, that is not a Z. I will never write the letter Z because I know my 2's and my Z's look about the same. So this is the first way that we would say it. Another way that we might say it is according to the vector, -3, 2. Okay, so these are 3 different ways that I'm saying exactly the same thing. Or my third way that I might say it is left 3, up 2. 3 different ways of saying exactly the same thing. So your translation is going to look the same, even though I'm telling you to do it 3 different ways, just 3 different ways of exactly the same. So translate that for me, please. I'll come and check you when you think you got it. All right, so if I'm going to the left, remember this is 3 different ways of saying the same thing. So to the left, 3. What I personally would do is I would just pick a vertex. So I'm going to start with the A and just count. So 1, 2, and 3 to the left. And then we know that it needs to go up 2 also. So from there, I'll go up 2. So my new A, my A prime should be right there. My B prime, 1, 2, 3, should be right here. Somebody check me though, because I know I most definitely have made mistakes before. And then last but not least, 1, 2, 3, and 1, 2. My new C, is that right?
Yeah.
Yeah, because it did end up. Okay, so I have exactly the same shape. It is just scooted to the left and then up 2. So when you're being asked to translate a shape, I would just start at each corner, start at each vertex, and count it up from there. Okay?